Want some GED math practice questions to help you get ready for the GED test? Then you're in the right place. Hi, this is Parker from Test Prep Champions, teaching you how to pass the GED fast. And you can get started by clicking subscribe down below. Let's get started. Okay, question 1 is to simplify, and let me read this so that you're clear on what my writing says here. So we've got parenthesis, 4 raised to the power of 5 times 7 raised to the power of 8, parenthesis, divided by, parenthesis, 7 times 4 raised to the power of 3, parenthesis, squared. So pause the video and try to simplify this now, and then we'll go over how to do it. Okay, so this question really tests you on your knowledge of your exponent rules in multiple different ways. So there are certain rules for exponent questions that you're just going to have to know like the back of your hand. So one is whenever you've got two numbers. So this is just a general rule here. So let's say that A is any number and B is any number, and we've got A times B, and let's say that we have a square here. So we have everything in the parentheses is being squared here. Well, we can think of A, or any number, as being raised to the power of 1, and we can think of any number as being raised to the power of 1. So what I mean by that is we could take any number, we could just take a random number like 4. Now, you wouldn't normally write this as 4 to the power of 1, but you could think of it that way because any number raised to the power of 1 is just itself. So 4 raised to the power of 1 just equals 4 here. So we have to start with that assumption here, right? So we've got, now what we're going to do is we multiply both exponents by the 2 out here. Okay, so this would become a squared times b squared. So hopefully that is clear here because this exponent rule is very important here. So what we see down here now in the denominator, the bottom part of our fraction, we have 7 times 4 cubed, and this is in parentheses. So this square here, this 2, okay, we're going to use our exponent rule. So this 7 here is just a 7, but we can think of it as 7 raised to the power of 1. So what we would do is we would do 2 times 1 here. So the bottom of our question here, we could just rewrite the bottom. We don't need to rewrite the top. It becomes 7 raised to the power of 2. Now what about this 4 here? Well, we've got this time 4 raised to the power of 3, so we do 2 times 3. So 2 times 3 is 6. So we have 7 squared times 4 to the power of 6. That's how the bottom is going to look. So we can leave the top the same here. So we have 4 raised to the power of 5 times 7 raised to the power of 8, and so we're not going to change anything on the top. So we've already applied this exponent rule here. And so hopefully it's clear that, let's say, if instead of a to the 1 times b to the 1, like if we had a times, let's say, b squared here, and this was raised to, say, the 5th power. Okay, here's how we would do this. So we would, again, just think of this a as a raised to the power of 1. So 1 times 5 is just 5. And then, so we've got this b here, and so b, we have to think, hey, this is b squared, so we have to do 5 times 2, which would be to the 10. All right, so that's important that you understand this. So hopefully you got that in your notes if you would like to. If not, you can pause the video, take your time. I'm going to leave the first general rule up here throughout the remainder of the video. So now let's keep moving here with the question. And so this information here that I'm giving you, this is not extra information or just information that I'm injecting in here. This is all stuff that's very crucial to know for your test here. So the next exponent rule that we have to understand is that when we've got two numbers that are the same base. So let's say we've got a raised to the power of b, and we're dividing by the same number now, a raised to the power of c. So the bases are the same. So in any exponent, right, or in any case where you've got an exponent, you've got the base and you've got the exponent. So here the base is a, the exponent is b. So up here, for example, when we have 7 squared, the base is the 7, and then the exponent is the 2. So in this case, 4 raised to the power of 6. 4 is the base, 6 is the exponent. So when the bases are the same and you've got a division question like this, so we've got a raised to the power of b divided by a raised to the power of c, where these are all, this could be any number here. This is just a general rule. We can rewrite that as a raised to the b minus c, all right? And we can really write that in parentheses. So we've got a raised to the b minus c. So how are we going to apply that exponent rule to the problem at hand here? Well, we see that we've got 4 raised to the power of 5, and down here we've got 4 raised to the power of 6. So we can apply that rule. So let's just think about our 4s, and let me box this out here to give us some room to work here. So we can rewrite the 4s So we've got 4 raised to the 5 divided by 4 raised to the 6. The bases are the same, so I can rewrite that as 4 to the 5 minus 6. And now with our 7s here, up here we've got 7 raised to the power of 8, and down here we've got 7 squared. So we can rewrite that, and we still have to leave our multiplication sign in place, as 7 raised to the power of 6. Okay, but before I leave that 6, let me show you how I got that. So we would just do 7 minus 2. All right, and so now we can simplify this. So I'm going to draw this arrow here showing that I'm going to rewrite this. So we have 4 raised to the 5 minus 6. So what is 5 minus 6? Well, that's negative 1. So we've got 4 raised to the negative 1 times 7 raised to the 6th. All right, so that's how we got that 6, was because we did 8 minus 2. So consider the problem that we had at the beginning, and now we're down to this 4 to the negative 1 times 7 to the 6th. This is a lot simpler. It's a lot clearer. All right, so there's one more exponent rule that we can apply here. So again, we're going to look at the general rule here. And these general rules are very, very important to understand. I know I've said that a few times, but I really want to impress that upon you. So when you have any number as your base raised to a negative power, okay, or a negative exponent, that's the same as 1 over that same base, but this time raised to the positive exponent. Okay, so here's our base raised to the positive exponent. So this is another general exponent rule that you'll want to understand here. So if we go back up to our question, we have 4 raised to the negative 1. So how can we rewrite that? Well, 4 raised to the negative 1, that is the same as that's the same as 1 over 4 raised to the positive 1. So now in our denominator, we could write 4 raised to the power of 1. So see what I'm doing here, right? So the denominator here, what we're doing is we have this 4 raised to the negative 1, and we're just moving it downstairs into our denominator, and it becomes 4 raised to the power of 1. And so we can leave our 7 raised to the power of 6 up here. And so now, since any number raised to the power of 1 is just itself, we don't really need to write 4 raised to the 1. We can just write 4. And so we have 7 raised to the 6th divided by 4. And so you can just punch that into your calculator, and you'll get a number like this. You'll get 29412.25. Okay, something close to this. All right, so this is our answer here. So it's either, you can have your answer as either 7 raised to the 6 divided by 4, or you can just do the math, do the calculation, and you'll get 29412.25. So either way, these are both, I would consider, the same answer, but I really wanted you to just understand these exponent rules. So if you got this right, give yourself an imaginary or a real round of applause. Good job. Question 2. A store charges $30 for a case of chocolate bars. Each case includes 3 packs of chocolate bars, and each pack contains 4 chocolate bars. What is the cost per chocolate bar? So pause the video and try this out. Okay, so hopefully you had a chance to try this. Let's go over it. So this question includes the concept of the unit rate. So the unit rate shows how many units of one quantity correspond to 1 unit of a second quantity. So this might sound a little bit confusing, but it's really not that complicated if we break it down. So a unit rate, you're going to take some kind of quantity. So let's consider miles per hour, for example. So let's say 45 miles per hour, right? So if we've got 45 miles as an example. So that's one quantity. So one quantity could be miles. So it shows how many units of one quantity correspond to 1 unit of a second quantity. Okay, so we've got 45 miles. So one quantity here would be our 45 miles. And so 1 unit of a second quantity would be the hours. So 45 miles per 1 hour here. Okay, so we've got 1 unit of our second quantity. So again, quantity 1 is the miles. Okay. And quantity 2, or the second quantity, would be the hour, or the hours, okay? But we're comparing how many units of one quantity, so here we've got 45 units of our miles, and we're looking at 1 unit of the second quantity, so we've got 1 hour. So that's all a unit rate is, all right? So for example, 45 miles per 1 hour, that's a unit rate. Okay, so we need to keep that concept in mind here. So what we're trying to find here is the cost per chocolate bar. So let me make sure that we're clear on that. So whenever you do a word problem, the first thing that I want you to always do is make sure that you're crystal clear on what you're trying to find here. So we want to find the cost per one chocolate bar. So I'm going to put CB for chocolate bar. So the cost of one chocolate bar. And so at the end of the question, we're going to look at our work and look at the answer and make sure that we've actually found the cost per chocolate bar. So that way we don't make mistakes and we don't calculate the wrong thing here. So now let's look at the information that we're given. So we're told that a store charges $30 for a case of chocolate bars. So $30 for a case of chocolate bars. So we've got cases, we've got packs, and then we've got the bars themselves here. So which is the biggest here? Well, $30 per case. So let's say you can get a case of chocolate bars, right? And that case includes what? So what's within that? Well, within the cases are the packs. And then what's within the packs? Well, within the packs we have our chocolate bars, right? So you've got your cases, your packs, and then your CB for chocolate bars. So we have the information that it's $30 for a case of chocolate bars. There are 3 packs in each case and 4 chocolate bars per pack here. So what we want to do is we want to take the cost of one case, we want to use that information to find the cost for one pack, and then we want to use that information to find the cost per one chocolate bar. Okay, so let's start with what we know here. So we know that it's $30 for one case, and the units are really the key here. The units are the key here. So we've got $30 for what? For one case. And I'm going to keep the labels in the work here because the labels are really, really important here. So we have $30 per one case. Now, how many packs are there per case? Well, we know that each case includes 3 packs of chocolate bars. So I want to set that relationship up here so that the case goes up here. So each one case includes what? It includes 3 bars, right? Or I'm sorry, 3 packs. So per case, we get 3 packs. And then what is our next step here? Well, if we do this, right, we've got the cost per case. So if we do this, we do 30 divided by 3. Okay, what's going to happen here? Well, the units are going to cancel out. So we've got case divided by case. That's going to give us dollars over packs. That would give us the cost per one pack here. All right, but that's not what we want to find. We want to find the cost for one chocolate bar. So before we do our calculation, we'd keep it going here. So we have this last relationship here that each pack contains 4 chocolate bars. So we've got packs and chocolate bars. So do I want to put the packs up here in the numerator of the fraction, or do I want to put the packs down here in the bottom part of the fraction? Well, we have to set this up so that the units are going to cancel out, right? So we know that each pack, so each one pack contains 4 chocolate bars. So for one pack, we get 4 chocolate bars. So I now have this set up so that the units will cancel out here. So we've got the cost of one case, right? And so we also have, in the calculation here, we'll find the cost per one pack. All right, and so I've set this up here that the packs are going to cancel out here, and so our answer when we do the math here is going to be left with dollars over chocolate bar. So the cost or the dollars per one chocolate bar here. All right, so let's do the math here. So we would do our calculation here. So we would do 30 divided by what? What is 4 times 12? So 4 times 12, or I'm sorry, 3 times 4 gives us 12. So we have our 3 times 4, which gives us 12 here. So we've got our 12 chocolate bars. So we have 30 divided by 12. And so the answer is, if you do the math, you're going to get about 2.5. All right, so we would find $2.5 per one chocolate bar. So the key to this question here is you just have to think about the units. You want to set up your calculation based off of these relationships. So when we see that each case has 3 packs of chocolate bars, we know that we can write this relationship right here, right? Each case has 3 packs of chocolate bars. And so right here we have 1 pack per 4 chocolate bars, so that just comes right out of our question here. So you just have to set up these relationships in such a way that the units are all going to cancel out until you're left with dollars over chocolate bars, and that tells you your cost per one chocolate bar. So again, the unit rate shows you how many units of one quantity correspond to 1 unit of the second quantity. So here our first quantity is dollars, and we're looking at how many dollars correspond to 1 unit of chocolate bars, and that's about $2.5 per one chocolate bar. Question number 3. Ruth takes her son out to eat and pays for both of their meals. The total cost of both meals is $28.72, and Ruth decides to leave a 20% tip. If Ruth had $55 in her purse before the meal, how much money will she have left in her purse after she pays? So pause the video now and try to figure this question out. Okay, let's go over this. So as always for word problems, we want to, before we get overwhelmed with all the details, we want to make sure that we know what we're trying to find. Okay, so let's clarify that here. So we want to find how much money she's going to have left in her purse after she pays. All right, so you can always put yourself in a situation like this when you're doing a word question, all right, to try to think through your strategy here. So we want to find how much she's going to have left after she pays. So next, let's look at the information that we're given here. So we're told that the total cost of both meals is $28.72. All right, so the meal is $28.72. So we're analyzing the given information here. So we know that the meal is $28.72, and we know that there's also going to be a 20% tip. But what's also important here is that we know that in addition to that 20% tip, we also have to factor in the fact that she started with $55, right? So she started with $55 here. All right, so again, whenever you're doing a word problem, the best strategy is to start by making sure you're crystal clear on what you have to find. Then after that, look at the given information and just analyze the given information. And from there, you'll start coming up with a strategy by considering the different operations, different keywords in the question, and an equation, because in many cases you're going to have to make one or more equations here. So one keyword that I see here is the word left. How much money will she have left in her purse after she pays? So the word left is a keyword that usually suggests subtraction here. So we can actually make an equation here for what we have to find. So we're trying to find how much money she's going to have left in her purse. So when you go to make your equation, you want to look at what you have to find. And so the first equation that you make is usually just going to be an equation that represents what you have to find. So that's another reason why it's so important to start by clarifying what you have to find. So we want to find the money left in her purse after she pays. So we can make an equation easily, right? So we can look at the money that she starts with. All right, so the money that she starts with minus the money that she spends, right? So we have start, then we have spent, so the money that she starts and the money that she spends, and that is going to equal the money that she has left. All right, so this equation here just represents what we're trying to find. So we want to find the amount that she has left, and so we have to look at the amount that she starts with, and we subtract what she spent, and that gives us what she has left. Now, the good news is that we already have one of these variables figured out. All right, so we have that the starting amount is 55, so we could just plug 55 into our equation here. But what we don't have yet is the amount that she spent. So in order to find this, all right, so in order to find the amount that she spent, we need to make another equation based off of the rest of the information here. So to start that equation, we can just simply start with spent because we're trying to find the amount that she spent. All right, and so what's that going to be equal to? Well, how about the cost of the meal, right? So she's got that cost to the meal here. So to figure out how much she spends, we have to factor in, okay, the cost of the meal or the amount that she spends on the meal. And then we've also got to factor in that 20% tip, right? So in the tip. So the amount that she spends is going to be equal to the amount spent on the meal plus the amount spent on the tip. All right, so now we have to look at our information. So we already do know what the meal is. So we know that the meal costs $28.72. So we can take this $28.72 and plug it in here into our equation to find the amount that she spent. But what we don't have yet is the tip. But we know that it was a 20% tip. So the way that we would find that tip is we just take the amount here, right? So $28.72. And we're going to multiply that by 0.2, all right? Or you can multiply it by 20%. So in a calculator, you could just do this. If you've got your calculator handy, you could just do 28.72 times 20%. All right, but if you don't have a calculator handy or you don't want to use your calculator to do a percent, you would have to know that 20% is equal to 0.2. All right, so 20% is equal to 0.2. So whenever you've got a percent, you just look at where the percent sign is in it, and then you move it to the left 2 places and change it into a decimal. So here's what I mean by that. So in 20%, we want to look at where the percent sign is. We want to move to the left 2 spaces. So here's 1, here's 2. And so instead of putting a percent sign here, though, we're just going to replace it with a decimal. Okay, so then we can cross out that percent. So that's how we would get 0.20. So let's say that instead of 20%, we had 2%. All right, so the same thing applies here. So to write the decimal, though, we would want to add some zeros in here. So we start where the percent sign is, move to the left 2 spaces, and then we would just put the decimal there, and then we can cross out this percent sign. So 2% as a decimal is 0.02. All right, so until you get the patterns about how to convert decimals into percents, okay, that's a trick you can use. Just take the percent, move it to the left 2, put the decimal there. So that's how we would get this 20% as a decimal if we weren't using a calculator. So now we're going to do this math here. So $28.72 times 0.2, what's that going to give us? Well, that will give us $5.74. So that's our tip, and that equals the tip here. So now we've got the tip and we've got the meal. So this value for the tip, 5.74, we can just plug that into the equation for the tip. So now we can figure out the amount that was spent because we know that the cost of the meal was $28.72, and we now know that the tip was $5.74. So we would want to just do this in our calculator for the sake of speed. You could add it by hand if you want to, but there's not much of a reason to. And for room, I'm going to put the equal sign down here. So we would add these numbers up here, and what are we going to get? So we would do 28.72 plus 5.74, and if you plug that in your calculator or do it by hand if you really want to, we would get 34.46, and so that is the amount spent. So now that we know that the amount spent is 34.56, we can just go back up and do our first equation here, and we can plug that into our equation here. So we know that the amount at the start was $55, and we know that the amount spent was $34.46, so we just subtract them. So let me do the final work for this question down here. So I'm going to draw a bigger arrow down here. So we're doing this calculation here. The start minus spent equals the amount left. So the amount she started with was $55, and so we figured out that the amount that she spent was $34.46. And so we would put that in our calculator, or if you really want to, you could do it by hand. If you want, you could try to do it in your head, but that's probably not the most efficient way to get the answer here. And we would do the calculation, and the answer comes out to be $20.54. So we think that we're done here, so let's just make sure that we solve for what we wanted to. We wanted to find the amount that she's going to have left in her purse, so we did that by looking at the amount she started with. We found the amount that she spent, and that gave us the amount left. So yes, this will be the correct answer here. So on a test, just make sure that you double check your work here. Obviously, you would want to double check these calculations on your test, but the strategy here, as long as you get that strategy right, double check your work, don't make any dumb mistakes, and you're going to get high points on your test. Moving on to question 4. For which value or values of x is the function f of x undefined if f of x equals x squared minus 8 divided by x squared minus 9? And you've even got multiple choice answers for this. You've got A is x equals 0, B is x equals 3 only, and C is x equals 3 and negative 3. So pause the video now and try to figure this out. Okay, hopefully you had a chance to try this out. Let's go over how to do this now. And so first of all, hopefully you know what a function is, but if not, here's just a quick reminder on it. I can't go into the concept that much, but basically a function just is a relationship between an input and an output. So know that a function relates an input to an output. So this f here is the name of the function. Now this could also be a g. We could, instead of f of x, it could be g of x or h of x, but in this case the function is named f, and so most of the time the function will be named f. So this letter out here just tells us what the function is named. And so this x here is the function's input. Okay, so this is the input. So like I said, a function relates an input to an output. All right, and so what is our output? Well, this whole thing out here is going to be our output. So the x squared minus 8 divided by x squared minus 9, this whole thing is going to be our output. Okay, and so the x, just note that it's really just a placeholder, right? Because we can input different numbers. So we could input 0 for x, or we could input 2 or 3 or 1 or 10 or 100. Okay, and we're going to get an output unless the function is undefined for that input. All right, and so I'm going to explain what that means here in a second. And so basically, hopefully you're getting the concept of the function here, but think about it this way. So let's say that we've got a vending machine here, and maybe in the vending machine, you put $1 in and you get a chocolate bar. And let's say if you put $1.50 in, maybe you get crackers. And if you put in, say, $2, maybe you get a soda. Okay, so you put in $2, maybe you get a soda. And so in this case, the input would be the dollar, your output would be your candy bar. You put $1.50 in, that's your input. The output would be crackers. Same with the $2. You put $2 in as your input, the output would be the soda. So as a very rough analogy, just think about here as we're putting inputs into the function, we get some kind of output out. So that's the basic concept here. Now, what you have to know is that there are cases where the function is undefined. So a function has a domain and it has a range. So the domain of a function is all possible inputs. So there are certain cases where we're not going to be able to put something into this function here, and that's what we're trying to find. So we want to find where is the function undefined, meaning, okay, what kind of inputs can we not put into this function here? And so there are two main cases that make a function undefined. So one is, so let me mark that over here because this is important to have in your notes. So because these questions do come up on the test, and this can really cost you points if you don't understand this. And it's really not that hard, okay? It just may seem like it. And so also note that in some cases you won't have a function like f of x. They might just write y. Like they might just write y equals x squared. Okay, so in this case, your input is your x, the output is whatever you're putting in. So like if you put in 2, you would do 2 squared, that would be your output here. But just note that in this case, the function is just called y, all right? And so sometimes when you might see y equals something like this, that's still a function, it's just that they're not using this function notation here. So sometimes you'll just see a y, sometimes you'll see function of x. Okay, and so there's two main cases when the function is undefined. So let me just make these as simple as possible. So one is divide by 0. So if you input a number into the function and it would result in you having to divide by 0, then the function is undefined at that x value. Okay, so what I mean by that is, let's say we put a certain number in here for x. If it makes us have to divide by 0, then we know that the function's undefined for that value of x. All right, and the reason is because you can't divide by 0. So you could take any number in the world that you want. It could be 100, 200, any number in the world. If you try to divide it by 0, okay, you're not going to be able to do that. You can't divide by 0. So division, you're dividing a bigger number up into smaller pieces of equal size. You can't divide something up into 0 pieces. That doesn't make any sense. You cannot divide by 0. And if you don't believe me, get out a calculator, try to divide some number by 0, and you'll see that you cannot do that. So one case is if you have to divide by 0, and another case is when you have a negative number under the square root. Okay, so any number, right? So when you've got a number under a square root when x is negative, right? So when x is a negative number. So if you've got a negative number under the square root, all right, if x is that negative number, and let's see, you've got a function like this where the square root in it, and you have to plug in some kind of negative number for x, like x, if you get this function, like say y equals square root of x, and you're given like some kind of negative number, or f of x equals the square root of x, and the x is -2 or something like that, know that the function is going to be undefined for that -2. All right, and same with anything that makes us divide by 0. So in this question here, we don't have any square roots. So that's the second case, right, that makes a function undefined, when you have an x under a square root and the x is some negative number. All right, that case is not going to apply here, so we're looking for what is going to give us a divide by 0 error here in our calculator. And so really we're just concerned with the denominator here. So in this fraction, we don't really care that much about the top part. We don't care that much about the numerator, okay, because you can have a 0 in the numerator. So you can do something like this, like you could do 0 over 100, and that just equals 0. So you can have a 0 up here, and you can divide 0 by 100, but you can't go the other way around. You cannot do 100 divided by 0, or any number divided by 0 for that matter. You cannot divide by 0. All right, it's okay if you have 0, all right, up here in the numerator, but you can't do 100 by 0. You can do 0 by 100, but you can't go the other way around, all right? So hopefully we're crystal clear on that. So the idea here is we want to take our denominator. So we don't care so much about the numerator, we just care about this denominator, this x squared minus 9. So let's think here, right? If we were to plug in x, or if we were plugging 0 for x, what would happen? Well, x squared minus 9. So what's 0 squared? Well, we just have a 0. So 0 minus 9 is what? It's going to give us negative 9. So if we plug in 0 for x here, all right, the denominator is going to be negative 9, because you would have x squared minus 9. If x is 0, you'd have 0 minus 9, which gives us negative 9. So that's not going to give you a 0 in the denominator. So a is out. Now what about b? So let's do some math here. So we're just going to take the denominator. We're going to take the x squared minus 9. We don't care about the numerator right now. We just care about this down here. So we have x squared minus 9. So let's take this 3, and we're going to substitute it in here for x. So let's say that we've got 3 squared, okay, 3 squared minus 9. Well, what is 3 squared? Well, 3 squared is equal to 3 times 3, which gives us 9. So we would end up with 9 minus 9, which gives us 0 here. So we know that the function is undefined if x equals 0. So for which value of x is the function undefined? One value for x would be 3. So if you have a 3 here, so if you try to input 3 into the function, you're going to get 0 in the denominator, which would result in a divide by 0 error. So we know that for one value of x that makes the function undefined, we know that one value would be 3. But what about negative 3? So here's another lesson here. So we've got this x squared minus 9. So let's plug negative 3 in here. All right, and so note why I'm using the parentheses here. So we have negative 3 squared. So negative 3 squared is equal to negative 3 times negative 3. All right, which gives us positive 9. So a negative times a negative gives us a positive here. So we would have this negative 3 squared minus 9, which is really 9 minus 9. So again, we would get a 0. All right, so if we plug in negative 3 for x in our denominator here, we're going to get 0. So we know that the function must be undefined for x equals 3 and x equals negative 3. So the answer here is C. Now, one more thing that I want to note, though, quickly, and this is very important to understand, is that the difference between parentheses, right, the negative being in the parentheses or the negative being outside of the parentheses. So if we had a case like this, like if we had something like this, like negative 3 squared, this would be a different answer because you would do 3 squared. So 3 squared gives you 9, but the negative is outside of that parenthesis here, right? So you would have negative 9 in this case, but that's not the case for this particular question, because in this case, we have x squared here, and we're just taking this negative 3, we're plugging it in for x squared, right? So everything gets squared. So the negative gets squared, the 3 gets squared, and that's why we get negative times a negative equals positive 9, all right? And then 9 minus 9 will be 0, so that's why C is the correct answer here. Question 5. If the area of a circle is 100, what is the diameter? Pause the video and try to figure this out. Okay, let's go over how to do this here. So this question deals with circles. So whenever you have a geometry question, if they tell you what the shape is, like circle, square, rectangle, or something more complicated that's not as common, then it doesn't matter what it is. If you know the shape, automatically you want to go to your formula sheet and you want to think of your basic concepts here. So let me draw a circle here. So this is what a circle looks like. So hopefully that is common sense for you, but if not, this is a circle. So when we take a circle here, and we draw a line from one endpoint to the other, this line tells us the diameter. So the diameter is a straight line segment that passes through the center of the circle, which would be about here, and it goes to a point on the circle, right? So its endpoints are 2 points on the circle, right? So you've got one endpoint here and one endpoint here. So the diameter, it has endpoints on the circle, right? Both endpoints are on the circle. It passes right through the center. So it's that straight line segment that passes through the center of the circle and its endpoints lie on the circle. So that's what the diameter is. So basically, in very simple terms, the diameter is just the straight line that goes from one end of the circle all the way to the other end of the circle. So let's keep it in stupid, simple, very easy to understand terms here. All right, and so the radius is half of the diameter. So the radius is just a line here, to keep it very simple, that starts at the end of the circle right here on one end of the circle, and it goes halfway through. So it goes to the center of the circle, and that's it. It doesn't go the full way through here. So the diameter, straight line that goes from that goes right through the whole circle, and the radius is a line that it starts on the circle and it goes halfway through the circle. So just keep that in mind here if we keep that in very simple terms here. All right, and so we can write the following equation. So the diameter is equal to twice the radius. right? Because we know that the radius goes halfway through the circle, but the diameter goes the whole way through. So we know that the diameter is equal to twice the radius. Now we could also write that as the radius is equal to half of the diameter. So d over 2 for half the diameter. So these are two formulas. One is for the diameter, one is to find the radius. And so now let's go through the question here. So we also see this area of the circle here. So the formula for the area of the circle is A equals pi times the radius squared, right? So the area of the circle is just pi r squared. And this little symbol pi, it's just a number that goes on and on and on and on. And you can think of it as being equal to 3.14. So it's not equal to 3.14 exactly. There's a lot of other numbers here, right? So this goes on and 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 on, but we don't really care. So just remember that pi is approximately equal to 3.14, okay? Or you can just think of it as equal to 3.14, but just know that it's really not. But if you ever have to do a calculation with pi, just use the number 3.14, but you don't always even need to use this number. You can oftentimes just leave the pi symbol here. So what we're told here is that the area of the circle equals 100. So in this case here, we can replace A for the area of the circle with 100. So we have 100 equals pi r squared. And so what do we really want to find here? Well, we want to find the diameter. So the best way to do that in this case, and there's multiple ways to do this, but the fastest way I think would be to solve for the radius. So we're going to solve the equation for the radius. So what we want to do is we want to get r by itself on one side of the equation here. So we've got pi times r squared. And then once we get the radius, we use the formulas up here, or one of these formulas up here to get the diameter. So back to the work here. We've got 100 equals pi times r squared, pi times r squared. So in order to undo this multiplication, we want to do division. Okay, so we want to get, again, the r by itself on one side of the equation. So the opposite of multiplication is division. And so whatever you do to one side of the equation, you also do it to the other. So we would then have 100 divided by pi, and I'm just going to leave that pi symbol in there. We're not going to do calculation using the actual number 3.14. So we have 100 pi equals r squared. But that's not really what we want, because we don't want r squared, we just want r. So whenever you have a number squared, like r squared, in order to just get the number, to just get this r, we want to take the square root. So any number raised to the power of 2, if you take the square root, you just get out this r here. All right, so again, the strategy is because r squared here, right, if you've got r squared and you put it under the square root, you just get out the r. All right, so whenever you've got anything squared and you take the square root, you just get that original number back out here. But as always in math, whatever you do to one side, you have to do to the other. So we've got to take the square root of this side as well. So we would now be left with this here. So let me draw a big arrow here. So you're left with the square root of 100 over pi. All right, and this is all over pi, right? Or this is all under the square root. So the square root of 100 over pi is just equal to r, because the square root of r squared is just r. So we can simplify this even further, because the square root of 100 is 10. All right, so we can rewrite this now as 10 divided by the square root of pi. That's equal to r. So we just found out what r is. But we want to find d here. All right, so we want to find diameter, not the radius. So all we have to do here is just multiply by 2. So we want to just multiply this by 2. So we've got 10 square root of pi. If we multiply that by 2, it gives us the diameter. So the diameter is going to be equal to 2 times 10 divided by 5. So what's 2 times, or not 5, divided by pi? So what's 2 times 10? 2 times 10 is 20. So the diameter is 20 divided by square root of pi. And so if you actually did the calculation, if you actually did the square root of pi in your calculator, you're going to get a funny number, but it will be the same answer. Okay, but I'm just going to leave my answer like this, 20 square root of pi. So that's the answer I'm looking for. But like I said, if you took it a step further, that's perfectly okay. And if you did the calculation, that's okay too. But this is what I wanted you to get how to do. Congratulations for making it to the end of the video. Your next step is to make sure you've seen my first GED math practice quiz and also check out my second GED math practice quiz, and then you'll be on your way to passing in no time. Thanks for watching.